Now we are going to see problem from the topics for gears. Let us see the problem. A gear drive is required to transmit a maximum power of 22.5 kilowatts. The velocity ratio is 1 is to 2 and RPM of the pinion is 200. The approximate center distance between the shafts may be taken as 600 mm. The teeth has 20 degrees stub involute profiles. The static stress for the gear material may be taken as 60 megapascal and the face width 10 times the module. Find the module, face width and number of teeth on each gear. Check the design for the dynamic and wear loads. The deformation or dynamic factor may be taken as 80 and the material combination factor for the wear is taken as 1.4 and the endurance limit is taken as 84 megapascal. So, if you see here the given data we have written here, the power is given P 22.5 kilowatts, that is if you convert into watts it is 22.5 into 10 to the power of 3 watts. Velocity ratio is given 1 is to 2, RPM of the pinion is given, let us say NP is 200, center distance is given, let us say x is equals to 600 mm and the system of teeth of gear is given 20 degrees stub involute profile. Here 20 degrees indicates the pressure angle and the static stress for the gear material is given 60 megapascal, that may be 16 Newton per mm square and the face width is given B 10 uh, times of the module. The deformation factor is given 80, let us take capital C, and material combination factor is given, let us say capital K dash 1.4 and endurance limit is given, let us take sigma E 84 megapascal or 84 Newton per mm square. So, this is the given data and here you see is asking module and face width, number of teeth on each gear means number of teeth on the pinion and the number of teeth on the gear, and here we have to check the design also for the dynamic and wear loads. Let us see how we can do this problem. So, in the first bit he is asking module. Module we can find module by applying the Lewis equation to the pinion or gear. Pinion or gear means in this set we have gear drive means we have one bigger, one smaller. Bigger one is called gear, smaller one is called pinion. So, here this Lewis equation is can be applied to pinion or gear. If this both are made up of same material, we will apply this equation Lewis equation to the pinion because pinion is weaker. So, the here the concept is we have to apply Lewis equation to the weaker of the pinion or gear which is weaker, for that we have to apply Lewis equation. So, if both gear and pinion are made up of same material, pinion will be the weaker. So, we have to apply Lewis equation to the pinion, and if both are made up of different materials, in that case we have to take the strength factor, that is sigma naught into yp. We have to multiply this, both sigma naught is the static stress for the gear material and yp, and we have to check for gear and for pinion both different are made up of different materials, means you will get sigma naught for pinion different value, sigma naught for gear different values are given. So, this sigma naught of gear and y of gear you have to multiply, that is called strength factor for the gear, sigma naught of the pinion and y of the pinion you have to multiply, that is called strength factor of the pinion, which you will get less. For that you have to apply the Lewis equation. But here if you see in our problem only one value for the static stress is given sigma naught 60 megapascal. If you see here also the static stress for the gear material may be taken as 60 megapascal, only one value of static stress is given, such that we will assume that both gear and pinion are made up of same material. So, only because only one static stress value is given. So, in that case both are made up of same material means pinion will be the weaker and we will apply Lewis equation to the pinion. So, applying Lewis equation to the pinion means you have to write here sigma naught of the pinion and here pinion and gear both of same. So, sigma naught only, and here y of that is y is called tooth form factor. So, y of the pinion you have to write. So, that is called applying the Lewis equation. So, here before applying this equation we require WT, and WT here it is called tangential tooth load, and this is given by a formula P by V into Cs. Here P is called power and V is pitch line velocity and Cs is the surface factor. And here P is given in the question and V is velocity, pitch line velocity we can find out with this formula pi into dP into Np by 60 or pi into dg into Ng by 60, whichever formula we can apply this or this, but here Np is given. So, let us apply this first one pi into dP into Np by 60, and here this next Cs I told we have to take from the data book, and Cv here we have to substitute Cv also. Cv is depends upon the pitch line velocity, and that is also we have to take from the data book. And here if you see B, we will substitute in the form of module which is given in the question, and Yp we will take from the data book and we will calculate, and we will do this will simplify to calculate module, and after finding out module we can find out face width and number of teeth, and checking for the gear for the dynamic and wear load means we have to find out static tooth load, dynamic tooth load and wear tooth load of the gear, and we have to see that static and wear tooth loads must be greater than the dynamic load for the safe design. So, this is the procedure we are going to follow here. So, first of all here we have to calculate dP to calculate V, and we substitute here and to substitute these values here. So, first step we have to calculate V. So, to find out V we require dP, and here to find out dP one clue is given, center distance is given, and center distance we can write like this, some small formula like this or some like this, x is equals to center distance, x is equals to dg by 2 plus dP by 2. How we can write, let us see. So, this pinion and gear are mounted on two shafts, and if you see this is the center to center distance between the shafts, where this is called pinion, smaller is called pinion, bigger is called gear. So, where these are mounted on the shafts. So, this from this center to this center, this is called center distance between the shafts, and let us see, if you observe here, this is the diameter or pitch circle diameter of the gear, and this is the pitch circle diameter of the pinion, and we require, if this distance we want means this is from here to here plus from this point to this point, and this is the half of the pitch circle diameter of the gear, and this is the half of the pitch circle diameter of the pinion. So, if you add this half and this half, you will get the approximate center to center distance between the shafts. So, it is nothing but dg by 2, that is pitch circle diameter of the gear by 2 plus pitch circle diameter of the pinion by 2. And here this dg will express in terms of dP. How means, here velocity ratio is given 1:2 means 1 by 2 you can write, that is Ng by Np, rpm of the gear by rpm of the pinion, you can write 1 by 2, and this is also expressed Ng by Np, you can write it is a, we know that from the velocity ratio formula, if you write Ng by Np, so you have to write reverse of diameter, that is dP by dg, and it is also equals to Tp by Tg for the gear drive. So, if you see from this we can say dP by dg is 1 by 2 means dg it is 2 times of dP. So, here replace dg by dP. So, dg by 2 plus dP by 2 is the first one formula, and from this discussion we know that dg is 2 times of dP means, so in the place of dg we can write 2 times of dP by 2, and dP by 2 is already there, and if you simplify this you will get 3 by 2 dP, and that is nothing but 1.5 times of dP, and that is nothing but center distance x, and the x value is given 600, that is center distance is given 600 in the question itself. So, when you simplify this you will get dP value as 400 mm, and if it is dP is 400 mm, dg is 2 times of dP means it is 800 mm. So, we got dP, and we substitute dP in the velocity formula, that is V is equals to pi into dP into Np by 60. So, but dP we got in the mm, but in this formula I have to substitute the diameter in the meters only, because pitch line velocity we have to substitute in meters per second in this formula. So, that is 400 mm is, that is 0.4 meters, such that you will get velocity in meters per second. So, here we are getting this as 4.2, when you substitute dP 400 mm convert into meters, that is 0.4 meters, and Np is the rpm of the pinion is given 200 in the question, and 60 is a constant here. So, when you simplify you will get 4.2 meters per second. and that you can substitute here, and here CS is the service factor. This we have to take from the data book, and here this, let us assuming the steady load is acting on this gear drive, and these gears are working 8 to 10 hours per service day. This is the assumption, because if you see friends, if you see in the total question, so there is any working hours or type of load is not given. So for that purpose, we will assume it is a steady load, and it is working, the drive is working 8 to 10 hours per day, such that CS value is 1. So this will have some table in the data book like this service factor. Here we have taken CS as a service factor, and in the data book it is K is given. So friends, in the different data books notations will be different, but we have to understand that notations, and we have to take the appropriate values. So if you see here, this is the table about service factor from the data book. Type of load is given, and your working hours are given. So nothing is given, and we are assuming steady load, and operating hours are 8 to 10 hours. So this here service factor we can take it as a 1. So CS value is 1 here. So when you substitute in this tangential tooth load formula, P is 22.5 kilowatts, and watts means into 10 to the power of 3, and CS 1, and velocity we got 4.2, and when you substitute you will get this tangential tooth load as 5357 newtons. And if you proceed with the next step, here we require this CV and YP values also to solve this Lewis equation. So this Lewis equation we have to solve to get the module. So to solve this we require CV and YP values that we have to calculate initially. So this CV is called velocity factor, which will depends upon the pitch line velocity, and its value also we have to take from the data book. So we got pitch line velocity as 4.2 meters per second, and when you see here, this velocity is pitch line velocities against which will have the CV values. So here some just correction is there. Just observe this. This is like this value should be like this only, and so we got 4.2 means it is velocity is less than 10 meters per second. So CV value is, we have to take it as 3 by 3 plus V, not 3 plus V by 3. So like this you can note that, note this correction, and so first 3 by 3 plus V we have to take for a CV, and when you substitute and this V value, and when you simplify you are getting CV as 0.417, and also we require this tooth form factor Y value. So here we are applying to the pinion, means we will write tooth form factor for the pinion. So Y P sub, here P stands for pinion. So this also depends upon system of teeth, that is how much is the pressure angle and how much is the this, what is the system of, it is a full depth or involute. So friends, when you see in the data, so friends, when you see in the given data, it is given the teeth has 20 degrees stub involute profiles. So here the pressure angle is 20 degrees, and it is a stub involute profile. So according to that you have to take the tooth form factor from the tables or from the data book. So if you refer to this data book for this tooth form factor, so 20 degrees and is given, and stub teeth is given in the that data. So according to that, this is the Y value you have to take, that is 0.17 minus 0.841 by Z. Here Z stands for number of teeth, but we are taking T. So notation, anything notation you can take any notation. So 0.175 minus 0.841 by TP. Here Z, instead of Z we are taking TP, and there Z stands for number of teeth, here T stands for number of teeth, and P for pinion. So but here TP, that is teeth on the pinion, is not given in the question, that you can write dP by m. How we can write, let us see. We know from the basic definition of module, it is the ratio of pitch circle diameter to the number of teeth. So when you apply this to the pinion, it is dP by TP, m is equals to dP by TP, and here we require TP. So when you send TP here, m come down, so it is TP is equals to dP by m. From that we have written like this, TP is equals to dP by m. So we got dP 400 mm. So here you have to substitute in mm only. Why? Because module is defined the circle diameter in mm by number of teeth. So according to that, so you have to substitute this dP in mm only. So TP will be 400 by module. So substitute the same thing here in this tooth form factor formula. So when you substitute TP is 400 by m comes upside, so it is 0.841 into m by 400, and when you simplify this you are getting 0.0021 m. So this is the YP value or value we got. So substitute in this next formula, that is Lewis formula, that is sigma naught into CV into B into pi into m into YP. So we got WT tangential tooth load, we got 53, 57 in the previous step, and sigma naught is given 60 megapascal or 60 Newton per mm square. It is given in the question. CV we have calculated, and face width B is face width, that is 10 times of the module given in the question. Pi is the constant and m is we have to calculate, and YP we got in the previous step as this YP we got, sorry, YP we got 0.175 minus 0.0021. So that here we have substituted here. So when you simplify this equation, you will get some quadratic or cubic equation that you have to solve in the calculator, and when you simplify you are getting approximately, we are getting it as 6.5 mm as a module, and if you go for the next standard module it is a 8 mm. So module, let us take it as a 8 mm standard module. So that is of the first bit, and here if you see the second bit we have to calculate face width, that is given 10 times of the module, means it is 10 into module 8, when you get multiply with 8 you will get 80 mm as the face width, that is the second bit we have to calculate. So it is over, and the third bit is asking to calculate the number of teeth on the both gears, means number of teeth on the pinion and number of teeth on the gear we have to find out. So in the previous step, if you see TP is, we have written dP by m. So dP 400 mm already we have done, and here m is the modules 8, here we got, so 8. So when you simplify you get it is a 50 for TP. So TP is the number of teeth on the pinion, 50 we got, and TG is 2 times of TP, because velocity ratio is given 1:2, that is Ng by Np is 1 by 2, but if you write Ng by Np, that is Tp by Tg you have to write, but here we have written Tg by Tp, so that is reverse, so that is 2 here. So this is ultimately from the velocity ratio we can write Tg by Tp is 2, so Tg will become 2 times of Tp, such that Tg is 2 times of Tp, means here it is 50, means Tg will become 100. So these are the steps. He has asked the module, face width and number of teeth, and if you see he is also asking to check the design for dynamic and wear load. So what we have to do to check the design for dynamic and wear load means, so we have to calculate three kinds of loads here. One is static tooth load, one is dynamic tooth load, and one is wear tooth load, and this static and wear tooth loads must be greater than the dynamic tooth load for the safe design. So first of all let us calculate static tooth load from this formula, sigma E into B into pi into m into y, and here we are doing the design for pinion, so it is a YP, and here sigma E stands for endurance strength of this gear material, which is given is 84 megapascal, which is given in the question itself, and here B is a face width module, and YP. In the previous step we got YP as some equation 0.175 minus 0.0021 m, and m we got 8, and when you write here and when you simplify this YP value you are getting 0.1582. Substitute here in this formula. So sigma is endurance strength 84 megapascal or 84 Newton per mm square given, and B is the face width, we got 80 in the previous step. If you see here, B is face width we got 80 mm, and Y is constant, module 8 mm we got, and YP is here you got 0.1582, and when you simplify this you are getting static tooth load as 26,722 newtons, and we have to calculate dynamic tooth load here. So dynamic tooth load is given by WT plus 21V into B into C plus WT by 21B plus under root of BC plus WT. Here WT is the tangential tooth load we have calculated in the previous step, we got 53, 57 newtons, and 21 is constant. V is the pitch line velocity we have calculated already, and B face width, and here C is the deformation and dynamic factor. This is called also, this is also called Buckingham equation, and in this equation C, capital C stands for dynamic or deformation factor, which is given 80 in the question itself, and WT is same tangential tooth load here, and if we, when you substitute all these given values and when you simplify this dynamic tooth load we got 10,630, and if you see next we have to calculate wear tooth load. So the wear tooth the formula is like this: dp into b into q into k dash. Here k dash stands for load stress factor or material combination factor, also you can call material combination factor or load stress concentration factor or something like that. So here in the question itself is given material combination factor for the wear is 1.4, means it is k dash. So and q is the ratio factor for which you can write the formula as 2 times of Tg by Tg plus Tb. So Tg we got 100, Tp we got 50. When you simplify, you get q value 1.33. dp we got 400 mm, the initial step itself. Face width is 80 mm and q here 1.33, and this is 1.4. And when you simplify this, we are getting wear tooth load as 59,584 newtons. So this is the wear tooth load. And when you see here, static tooth load 26,000 something, dynamic tooth load 10,000 something, and wear is 59,000 something. So here static and wear are more than the dynamic. Dynamic is only 10,000 around. We got static is 26 and wear is 59. So both these static and wear loads are greater than the dynamic load. So the design is safe. So here these formulas, friends, you may feel that it is a very big formula, but as we know, we have data book. From that data book we can find out some formulas like dynamic fd is a dynamic tooth load. Here we can get directly from the data book itself the formula, and fw stands for wear tooth load. Here friends, if you see, we have taken ww, wd is for dynamic, but here if you see in the data book fd, so here the change of notation, we are taking w for the load or load, and but he is taking f for the load. So such that you can find out formulas here. And also if you have any confusion, just in the starting of the chapter in the data book, just we have, they are given some symbols for that, they are giving meanings. So when you refer that symbols and the meaning for that symbols, and when you refer the formulas, so such that any disturbance is there from the textbook notations and data book notations, you can clarify that. But the formula will be same anyway, more or less it is same. So if you see here, we have taken wd. So W is notation for load. He is in the data book he is taking F for the notation. This the remaining formula is same thing. So WD is Ft plus Fi. Here this second term is nothing but incremental load, that is Fi or Wi here. So he is taking Fi here, and Fi meaning is given 21V. Same thing if you see friends, 21V BC plus WT. Here also 21V BC or CB. Ft WT in the place of WT is Ft. So the formula is same thing here, and C value is directly given in the data book. Otherwise, if some E1, E2 means E1 is the Young's modulus of the pinion, Young's modulus of the gear. So that values you can find from the tables from the data book. So anyway, these formulas, dynamic, static, load, these formulas you can find from the data book. Just refer to the data book. And here if you see wear tooth load, we have written the formula WW is equals to dP into B into Q into K dash. But here a small little bit in this formula, a little bit difference. We have taken dp, here is taking d1, 1 stands for pinion, b is same thing face width, q same thing we have taken, and the formula kw he is here taking, and we have taken in our formula k dash, where k dash stands for material combination factor for wear, and here the kw also same meaning. So a little bit changes are there, just follow this notations and symbols from the data book such that you can get the formulas, some of the formulas from the data book itself. So this is the way to solve the design of Spur case problem. So friends, for more videos, please subscribe and activate bell symbol. Please like it, share it, and don't forget to subscribe. Thank you.